Hi, good afternoon. In today's introduction to an academic paper, I'll present sub-lexical translations for low-resource language, which is presented at the proceedings of the workshop on machine translation and parsing in Indian language, and which was researched by the University of Electrocommunications in Tokyo with relationship with the Entity Corporation. So the motivation of this research was to improve information access for low-resource languages. So the source and target languages of this research are English and Bengali. So Bengali language is spoken by about 230 million speakers all over the world. So as we all know, most of the web contents is written in English, and those people who only can understand one language or monolingual speakers don't benefit that much from the internet because they don't get the documents which are written in their native language. So the motivation of this paper is to provide more information for those categories of people. So in this paper, the problem that they tried to address was low coverage issues due to out of vocabulary words, and the method that they proposed is sub-lexical translation to achieve more wide coverage of these unknown words during machine translation. So previously, for Bengali language, there was a research on rule-based machine translation to research, and also statistical machine translation, which is presently added to Google Translate. But the authors identified that the systems did not consider or perform low on out of vocabulary words. So sub-lexical unit is a part of a word which has independent meaning. For example, this bluebird is one word, but it has two sub-lexical categories or units, which are blue and bird. So identifying this kind of sub-lexical units was effective in finding translation candidates during English Bengali translation. The translation candidates, the identification of those translation candidates was better when they divided the units of the single word into its sub-lexical units. So previously, the same authors also researched on this area, and this is an architecture which they have come up with that research area. And in this research, they added this handling of out of vocabulary words. So this is the contribution of this research. So in this architecture, first there is the source language, which is English, and by using Open NLP Chunker, the input sentences they are processed to find out the chunks in English. So here, source language analysis to find out the chunks. And then once these English chunks are generated, there is a matching algorithm here, which tries to match the chunks with so-called CSTs, which are chunk string templates. So these chunk string templates have English chunks and Bengali strings. In this next slide, we can see the example. This is chunk string template table. So these are chunks, phrases, noun phrase, verb phrase, and so on in English. And this is the string, which is a translation of this chunk. So in this second step, there is a template of these chunks, and the English chunks are matched with these templates. So once chunks are matched, they are reserved as candidates. And to find out, in case there are out of vocabulary words in these candidates, WordNet is used to find out candidate words for these chunks. And then the candidates are generated, and by using a bilingual dictionary, they come up with the target language sentences. So this is the parallel corpus that they worked with, and this is an example of its construct. So for this English sentence, this is the Bangla translation, and the alignment is given here. So this first word is aligned with the last word in the English statement. And these are the CST templates. And from these, they generalized some of the rules for nouns, proper nouns, and cardinal numbers. So these are some of the generalization rules. For noun phrases that have pronouns, they come up with this noun communication, which is a general category of this from the WordNet lexical files. So they prepared these three types of resources. So the main contribution in this paper is handling out of vocabulary words, and this is the algorithm they used in order to find out a solution for identifying translation candidates. So the input is words, out of vocabulary words, and they have these three dictionaries. One is English to Bengali dictionary, another is this CST templates, and also WordNet in English. So from the WordNet, related words are extracted, and these related words become the candidates for translation. So if the candidate exists, then the candidate is returned. If it doesn't exist, it is simply transliterated, because they didn't find a matching word. So they, as it is, they just transliterate the word from English into Bengali scripts. But if it is found, then it is returned. So they used a ranking algorithm in order to rank out the translation candidates. Before that, to find the sub-lexical translations, what they did is first find possible sub-lexical units, as we see in this example, and then by using the WordNet, extract the meaning of these sub-lexical units. And by using the ranking they used, they removed less probable sub-lexical translations, and the output is the translation candidates with their part of speech tags. So this is the process or the steps they used to find out sub-lexical translations. In the criteria for selecting, they had an algorithm which matches the input and the templates. So level 4 is exact match, and so on. Level 3 is only partial match. Level 2, it doesn't include part of speech tags. Level 1, only part of speech tags. And level 0 is there is no match, it is out of vocabulary word. So while finding candidate translations from WordNet, they used the WordNet synsets such as synonyms, antonyms, and hyponym and hypernymy relationships. So for synonyms, nouns, proper nouns, verbs, adjectives, and adverbs, they get information of those part of speech categories. And for antonyms, if the word is not found as a synonym, by finding its antonym, they can come up with the translation candidates. For example, unfriendly. If this word is not found, then they try to search for friendly, and then they negate the result. So for hypernymy relationships, their search algorithm tries to find the matching from the lowest level. If it is not found, it goes on into the higher categories. But if the match is found in the lower categories, it's considered as the most suitable translation. So as an example, considering dog is out of vocabulary word, the WordNet returned these categories for dog. So dog can be a domestic dog or Canis familiaris, and also if we go to the hypernymy relationships, it goes into the more general animal relationship. So these are all possible candidates for translation. So which one is going to be chosen from these as a possible translation? For that, they have a ranking candidate. They have a ranking algorithm for choosing candidates. So what they used is they used the most frequent or the highest hit from Google searches. So the one which has the highest hit is considered as the most suitable translation. So they did phrase search and also neighboring chunk search. If they cannot find it in the phrase search, they try to find from the neighboring chunk search. So for example, this is the sentence: this dog is really cool. It has 37,300 hits in Google search. So the other highest candidate for this is the animal. So highest Google hit for animal is this much, and it's better than the others. So it's considered as the most likely translation of the dog. If they cannot find, if the phrase search returned less than 10 results, then they consider neighboring chunk search by using the other hypernyms of dog. So the mammal is, the canid is, and so on. If this also fails, then they just transliterate the word as out of vocabulary word. So finally, the experiments and results. The translation quality or evaluation is done by humans. They had 2,000 aligned parallel sentences of English and Bengal, and they generated out of these 2,000 sentences these chunk string templates, 15,356 templates, and so on. And these are the levels of quality of the translations. So perfect means exact match. Good means understandable for humans. Medium is there are some mistakes, wrong word choice or wrong word order. And poor translation is non-translated words. So as we can see, the baseline, there are some improvements when comparing these new results of sub-lexical translation with the baseline results. So this is the short introduction of the sub-lexical translation that they did in this research. Thank you very much.